In this video, we're going to look at some of the basics, understanding, and rules that we use when we're working with percentages. In statistics, of course, we'll be doing a lot of work with percentages, so some of this may already be familiar with you, and some of it may be brand new. So let's just start off with the kind of the first idea here is what does a percentage actually mean? We see these a lot of times when we're looking at polls and results of polls, etc. So a percentage is a way for us to, and I'm going to use this term, relativize, which relativize means make it relative to, right? So we want to relativize a comparison of two numbers. And in a comparison of two numbers, we generally see those, or we call those a ratio, which also is generally in the form of a fraction, but isn't always in a fraction, to what it would be compared to the number 100. So it's a way for us to take a comparison of two numbers and say, okay, this is what that comparison would be if I was comparing it to 100. And in fact, the word percentage, percent, actually suggests the per 100. There's 100 cents in a dollar, right? So per 100. And we symbolize that with this symbol, excuse me, the percentage symbol, as you know. So just to go through a, just kind of an example here, if we have a half, we know that equates to half of 100, or 50 out of 100. As a decimal, if we divide 50 by 100, that actually moves that 50, or the decimal, which would be at the end of 50 there, would move it back 2 spots. Whenever we divide by 100, it moves it to the left, the number of zeros that we have in the multiple of 10. So with 100, it moves it back 2 spots. And then we express that as 50%. So 50 per 100, or 50 for every 100. So let's just go through some basics of how do we go from like fraction value to a percentage? How do we make that sort of transition? So one of the ways to think of this is to think of it in terms of a proportion. A proportion is when we have one fraction set equal to another. And fractions are one of these few things that we can do this with, because as long as the relationship between the top number and the bottom number is similar, any fraction can be expressed in an infinite number of different ways. Our focus, of course, is to compare it to 100. So one of the ways that we do this is simply by multiplying the top and the bottom by the same number, right? So if I know that I want to have 100 and I have a 4, then I know if I multiply 4 by 25, that'll give me 100. Well, the rule is if we do it to the bottom number, then to keep the value of the fraction the same, we have to multiply the top number by the same value. Because if I'm multiplying by 25 over 25, I'm really multiplying by 1, which anything times 1 is still equal to its original value, right? 5 times 1 is still equal to 5. So 3/4 times 25 on both the top and the bottom is the same as going 3/4 times 1. So I know I'm not changing its value, and so this would give me 75 out of 100. Now, sometimes you have a number that doesn't multiply evenly into 100. So we need another sort of methodology to make that transformation. Well, one of the things that we see with fractions that are equivalent, in other words, with these proportions, is that if we take the numerator of this and multiply it by the denominator of the other fraction, so in other words, if we go 75 times 4, and then we also go 100 times 3, is that when we do this multiplication, we get two numbers that are equal to each other. And that's true if the fractions are actually equivalent, right? If they're actually proportional to each other. And so if I put a variable up here, we can use that idea that if A over B is equal to C over D, then, actually let's use caps to be consistent there, then A times D will be equal to B times C. If I use that principle, we can say 9 times X should be equal to 4 times 100. So 9x equals 400. And so if I divide both sides by 9, I get a value for x. Solving that equation for x, of course. 400 divided by 9 is 44.4 repeating. Now, unfortunately, unless I put it in exactly like that, so I could say 4 over 9 is equal to 44.4 repeating over 100. Okay, that would give me the actual thing here because we get 44.4444 onto infinity. But if I round it to 44.4, that's not an actual equals, so I'm going to write up here. Let's say, and this is the problem that we run into with a lot of fractions converting them to decimals. If I just say 44.4 over 100, this is actually not true. They're not equal. They're close, so we could say they're approximate. And if that's the case, whenever we say approximate, we want to use those little kind of squiggly equal sign symbols. So at any rate, rounded to the nearest tenth, this would be the answer for that particular problem. So the main idea and why I even showed you this particular way to do this, because it's not actually the easiest way, but I do want you to see that sort of transformation from fractional form to fractional form, where the other fraction is simply a fraction with 100 in the denominator. Remember that percent means per 100 or divided by 100, divided by 100. So the number here on top, 44.4, would be my percentage, right? So, so the 75 over 100 is equal to 0.75. If we actually take 75 and divide it by 100. But let's actually, let me just write this. And we'll this is kind of skipping over that other step there. But 75 over 100 is 75% per 100. And 44.4% is 44.4 divided by 100 per 100. Let's look at a kind of an easier way to do this. Instead of trying to do it via looking at it from a proportional standpoint, there's a bit of a simpler way we can do. We can go from fractional form to decimal form. And remember that a fraction is simply a statement of division, right? This is the bar there is a division. So this is saying 3 divided by 4. If we type that into our calculator, we get 0.75. This is the decimal value of 3/4, 0.75. Now, if I want to percent what 0.75 would be as a percentage, I want to show you something real quick here. This, in fact, we say 0.75, but really this is 75. 5 is in the hundredth spot. We have the tenths, and then we have the hundredths. So that's 75 hundredths, right? 75 hundredths. And that is 75%. So even saying it's 75 hundredths is, 75 out of 100. Hundredths with THS means out of. So, in other words, looking at it from here to here, what did we do? Well, we took the number. If I wanted to express it as a percentage, I multiplied it by 100. Now, why did I multiply it by 100? Why did I move it? Because the decimal now is right after the 5. Well, the reason I wanted to multiply it by 100 is because I'm attaching this symbol. And this symbol means per 100 or divided by 100. Right? So, think about what I've done here. I took 0.75 or 75 hundredths. I multiplied it by 100, which moves the decimal 2 spots to the right. And you can, whenever you multiply by something that's a multiple of 10, you move the decimal to the right, the number of zeros that are part of that multiple of 10. So if I was multiplying by 10, I'd move it 1 spot because there's 1 0 in 10. If I multiplied it by 1,000, that would move it 3 spots. But with 100, we move it 2 spots. And if I multiply by 100 and then divide by 100, notice that I've undid the multiplication. And the percentage symbol means divided by 100. So in other words, I haven't changed its value. 0.75 was multiplied by 100, which would change its value. But then we attach this symbol, which means divided by 100. And so really it retains the same value as 0.75. In other words, 75% is equal to 75 100ths or 0.75. This is the actual value of 75%. Notice that 75% does not have a value of 75. Now, it's one of the reasons why in statistics, whenever you see a variable that you're supposed to replace with a percentage, you always want to put it in its true value form, not in its percentage form. We never actually plug a 75% into an equation or into a formula, because 75% does not have a value of 75. It has a value of 75 out of every 100, or 75 100ths. 4 divided by 9. Again, so if I go 4, top number, divided by 9, the bottom number. So we go in order, top to bottom. 4 divided by 9 gives me 0.44. 4, and it is repeating. All right. So if I multiply this by 100, this moves the decimal 2 spots, so it gives me 44.4 repeating. But since I multiplied by 100, I also want to divide by 100, so we need to put on that symbol, percent, which means divided by 100. Okay, so now that we know how to go from a fraction to a percentage, how do we go from a percentage to a decimal? Generally, we're going to go from decimals to percentages, percentages to decimals. We generally don't, sometimes they start out as fractions, but we never really generally will go from a percentage back to a fraction. So, no, really this would be the same principle that we just showed, but in the backwards way, right? So the key to converting back, and this is actually something you want to always keep in mind, because this will help you remember what to do, is remembering the meaning of the percentage symbol. The percentage symbol, of course, means per or divided by 100. This means that to convert to a decimal, so we're going from percentage to a decimal, we need to divide the number you see by 100. All right, so in other words, 1% means 1 divided by 100. Well, 1 divided by 100 is 0.01. And sorry, that's not an approximation. I don't know why I put it that way. Let's just put in equals, because that's equal. Or that's exact, right? If it's exact, we can put equals. If it's about, we can put the approximation symbols. This would, in fact, be the decimal equivalent. 1%, or 1%, is 1 divided by 100, which is 0.01. Notice that in practicality what I did was I took the 1% and I had a decimal after the 1, and we took that, and when we divided by 100, we ended up with 1 with moving the decimal from where it was back 2 spots. So we divided by 100. When we multiply by 100, we move the decimal to the right 2 places. And when we divide by 100, we move the decimal to the left 2 places. It's always equal to the number of zeros that you have in that multiple of 10. So, let's continue to carry that on here. With 75, remember decimal being here, we would move this back 2 spots. And so this is equal to 0.75. 235%, which is strange. I know it's more than 100, but here's our decimal. If we move it back 2 spots, that gives me 2.35. And with 2%, and I wanted to change that to a decimal. Remember, the percent means divided by 100. Divided by 100 moves it to the left 2 spots, so that gives me 0.0002. 2 spots from where it was. I actually have 3 zeros and a 2 rather than just 1 0. These can be tricky, so you always want to remember this symbol means percent. Per 100, divided by 100. So if I want to get rid of this so I can express it as just a number without the symbol, I need to actually carry out that division by 100. And then to add that symbol, if I start out with 0.01 and I want to express it as a percentage, we want to multiply by 100, right? Make it 1.0. And then to balance out the fact that I multiply by 100, I put the symbol on there, which the symbol means divided by 100. So I balanced out that multiplication by 100 with a implied division by 100. So some general things to keep in mind. These are concepts or ideas that you just want to kind of remember as you're going through. These are kind of like the, hey, I can always count on this to be true. Like I've said a number of times here, the symbol for percent is read percent, which means per 100 or divided by 100. And so as we saw, if we convert from a percentage to a decimal, we want to lose the symbol. We already have a symbol. So we carry out the division by 100. In other words, if I had 25%, I want to lose this, so I take 25 and I divide it by 100, which is 0.25. It moves that decimal, which is after the 25, back 2 spots to its new place. And one thing you can always remember that the decimal form of a number is always going to be smaller than the percentage form. I mean, in actuality, they're equal. But in other words, 25 is more than 0.25, right? But 25% is actually equal to 0.25. All right, the second thing is, if we convert to a decimal to a percentage, we want to add the symbol, right? We want to be able to tack this symbol onto it. The symbol means divided by 100. And so before we can do that, we have to do the opposite of division, and we have to multiply by 100. So 0.003, if I want to express this as a percentage, like what percent? This already means divided by, actually let's put divided by 100. And so if the symbol means divided by 100, then to balance that out, I want to multiply by 100, which moves the decimal 2 spots. So 0.3% is equal to 0.003. And in general also, when we multiply by a multiple of 10, we move the decimal to the right equal to the number of zeros. And for 100, then if we multiply 100, it makes it bigger. And if we divide by a multiple of 10, we're moving the decimal to the left equal to the number of zeros. And so if we divide by 100, it makes it smaller. Those are just general kind of basic stuff to keep in mind. So let's look at doing some things with percentages. One of the things that, percentages, when we talk about them, they have to be based on something, right? The percentage itself has a basis of 100. But if we're looking at a percent of a number, then we're looking to take a portion of that number. Another 5 out of 100 would be 5%, or 5 out of 100 would be equal to how much of 30? In other words, of this number, what would be the number that would represent what would be the equivalent of 5 out of 100? So this is one way you can solve these. And this is called the proportion method, where we take percent out of 100 and set it equal to something over of. And the reason I put is over of is because this can help us figure out where these numbers would belong in this, right? So what the question is, 5%. Well, 5%, this I know is my percentage, so I know this goes here. And it's always over 100, so 5 goes over the 100. The is part, notice the is on the top, is our what. So in other words, this is my unknown. What is, right? So is, and the of is going to the 30. So the 30 goes down here. And then we have a proportion like we saw earlier, right? So I can go 5 times 30 is equal to 100 times x, or 100 times what number? This, of course, is 150. And so we have 100x, did I do this right? 5 times 30. And then all we have to do is solve this for x. So we divide both sides by 100, and we get x is equal to 1.5. Okay, so this is doing this in a proportional way. Whatever our percentage is, that goes over the 100. So we have the percent over 100. 100 kind of always stays there. And we set that equal to the is over of. So let me show you another sort of example of that. Let's say we had 30 is 10% of what? So here we've switched up the of, or the part that's missing. So notice what's given to us here is the 30. 30 is. So is in the top part of the fraction. So in my blank over 100 equals blank over blank, I know 30 goes up here. And 10 is my percentage, so that goes over the 100. And what we want to know is of what? So the unknown here is the of. And we can do the cross multiplication, right? Oops, I know that got in there. So let's try that again. We'll go 10 times x equals 30 times 100. So 10x equals 3,000. And if we divide both sides by 10, oops, I divided by 100 there. I get x is equal to 300. So we see that 10 over 100 is equal to 30 over 300. We can see this works because 10 times 3 is 30, and 100 times 3 is 300. So these are proportional fractions. the percent could also be unknown. So we could say 5 is what percent of 70. So the unknown here is the percent, x, so the part over 100. 5 is my is, so 5 goes up here. Of is 70, so 70 goes down here. So we see 70x equals 5 times 100, or 70x equals 500. Divide by 70, I get x is equal to 7.14. And this is an approximation, so I'm going to change this to approximately. So this would be my percent. It's not given to you in decimal form. The way that this is set up, it's actually given to you in percent. So we would say 5 is 7.14% of 70, which should make sense because if you think about what would be 10% of 70 would be 7. 5 is less than 7, and so it's a lesser percent than 10. There is another way to do this, though, that I think is a little more straightforward than doing it from a proportion standpoint, but I do want you to see those connections between the fractions, the proportions, as well as the decimals. So what I like to call this is kind of the direct translation way to do these problems. Keep in mind that of always means multiplication, and is equals, equals. Okay, that's pretty easy to remember. Is equals, and of always means times in mathematics in general. So we can actually do a direct translation here. What means that we want to know this, right? So this is kind of my unknown. Is translates into equals 5%. Now, of course, we want to change that to its decimal value. So this would be 0.05 of means times and 30. So we have this actually set up now for us to find the answer. We can say x is going to be equal to 0.05 times 30, which is 1.5. All right. This actually is a little bit easier, I think, than putting it into the percent over 100 equals is over of, because it's just a little more direct and you kind of can just translate it. Remember that a percent will always have something that's a percent of, right? In other words, let's say a shirt was $30, but it was 5% off, right? So if I want to know how much is taking off, I want to take 5% of $30. And so we would see that would be $1.50. So not a whole lot. But and it's easy if you think about 10 is always moving it, like 10% of something is always moving the decimal back one. So 10% of 30 would be 3. 5, of course, is half of that. So 3 divided by 2 is 1.5 or 1.5. So 10% and what that's equal to can be kind of a helpful thing to always keep in mind. 10% is 1 less 0 of our number. But percentages always have to be a percent of something. So we want to look for that keyword of, because that tells me what we're going to multiply by the percent, because of course, means multiplication. So for our second example, we had 30 is equals, this is 10%, so 0.10 of x. This is my what number, right? Of meant multiplication. Then we have our unknown. So in other words, 0.10x equals 30. So if I want to solve this for x, I need to divide both sides by 0.10, which gives me 300. Again, straight up algebraic way of solving this. 5% is what percent of 10? I'm sorry, I said 5%, but it's just 5. So 5 is equals what percent? So x times 10. And so this gives me 10x equals 5. Divide both sides by 10. We say x is equal to 0.5, which is 50%. Now here, I put x, and so for what percent, I just put x. So this is going to give it to me in decimal form, and so I need to turn it into this, into percentage form. Another way to do that would be to go 5 equals x over 100 times 10, and then the x would be in its percentage form like it was on the previous way we did it. But this is a little more kind of complicated to do it this way. So when you do a translation, if it's the percent you're after, you have to convert it at the end into a percent. And then think of the logic of it, right? Is 5 half or 50% of 10? Yeah, of course it is. So you can always feed it back kind of into the problem to make sure it's reasonable. Going back to number 1 here, 1.5 is a small percent, right, of 30. Remember, if it was 100% of 30, it would be 30. But if it's smaller than 100, like 5, you know that it has to be a smaller number than 30. And a fairly small one at that. Over here, we had 300. So is 30 10% of 300? Does that make sense? If we take 10% of 300, would that give me something as small as 30? And yeah, 10%, that's one of those things where we can just knock a zero off and we have the number, the 10% of. This, I hope, gives you some tools that you can use to work through some of these percentage problems. Always remember to also use the discussion boards for questions that you're running into. Think about the meanings here for when we talk about a percent of something, and that it always involves multiplication. And is generally gives us an idea of what we're trying to find. That's our equals. Good luck.